Hi, my name is John, and I will be going over Stewart 6E, Chapter 2, Section 7. It's called Derivatives and Rates of Change. Just sit back, enjoy the lecture, and uh, hopefully you can kind of absorb the material as you go. You can take notes if you want or stop it, okay? So I make up some notes right here. This is what I'm going to be going over today. There's going to be part one and part two because it is somewhat of a long lecture for the rates of change and derivatives. Okay, so what's a derivative? Derivative basically is the tangential line. So if you have a curve like this, that's called a tangent line or m of tangent. We use m for slope, right? And the slope of the tangent line is right over there. If I go like this, it goes through 2 points. It's called a secant. You put M-S-E-C for secant, okay? So you have two types of slopes. A tangent slope, which is hitting at one point. It does not go through here like this. Rather, it has to be on the outside, okay? And also, you also have the secant slope as well, going through 2 points, right? So we use m for slope. By definition, that means it's defined as slope is defined as rise over run. Of course, you already know what that is, and that's called your slope. And the equation now becomes y2 minus y1 over x2 minus x1, right? You already know that too as well. Or we want to call it change in y over change. This delta means change in x. Okay, it's the ratio of the change in y versus the change in x. Okay, so let's try a simple example. Let's try. I'm going to draw a real simple problem like this for you, and I'm going to draw a line right there. Let's call this point A right over there, and here's your function f of x. This is called your secant slope, right? And would be your secant line then. Let's say it goes through this point right here at x1. So the y point is, according to this function, it will be f of a, and according to this function, it's going to be f of x1. So the slope, m, secant slope, is defined as change in y, f of x1, minus f of a, all over x1 minus a. Okay, that's your secant slope. You notice something right here. Make a triangle. This is your rise, and this will be your run. Okay. What happens when x1 approaches a now? We call that the limit as x approaches a. X1, I'm just going to call it x instead of x1 right here, okay? As x approaches a of f of x, how would that work? F of x minus f of a, that would be kind of like the secant function, all over x minus a. As x approaches a right now, it becomes 0. And so you're going along this point, and then you're going to have secant, 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 and finally you're going to end up with a tangent line right there. There's your tangent. Okay, that's by definition f prime of a, or we call it slope m tangent. Okay, so those mean the same thing. So I should have wrote it a little bit better, but anyways, so it's the change in y over the change in x, and the limit as x approaches a. We call it f prime of a. That would, another word for prime means derivative. Oh, you hear the word derivative now, right? Derivative means just a change. It's basically tangential slope. Okay, at this stage. We covered most. So I'm going to do example number 1 for you. Example 1 on page 144. It says that y is equal to x squared at x equals 1. I want you to find the tangential slope. Okay. F prime of 1. This is your a value now. Of a, by definition, is f of x minus f of a all over x minus a, and the limit as x approaches a. And so what we're going to do is we're just going to plug in 1, since our a value was 1 right here. We'll plug in 1 in here, 1 in here, and 1 in here. So f prime, the derivative at 1, x value equals 1. That's how you kind of read that. F prime of 1 is equal to limit as x approaches 1. F of x is just x squared, right? Minus f of 1, according to here, f of 1 is equal to 1 squared, which is 1. So it's going to be minus 1 over x minus 1 right there. Do you notice that this is the difference of squares? So you can factor that. You cannot actually plug in 1 here, because 1 minus 1 is 0. 1 squared minus 1 is also 0. So you get 0 divided by 0. So you can factor that. It becomes x plus 1 times x minus 1 all over x minus 1, right? And notice now, these conjugates, one of them is going to cancel with this x minus 1. So the difference of squares always factors to its conjugates. Now you can plug in 1 in here now. I'm going to use light green. Since it's 1 here, now you can plug in 1 in for your x. And so f prime of 1 is equal to 1 plus 1, which is 2. That's your slope. And I'm going to use a different page for this. I'm going to show you how that works, kind of. So y equals x squared looks something like this. And then at 1, if you took the tangent, it should be 1 right there as well. If you look at the slope of the tangent, first of all, it's positive, right? And since you go through this point, the slope tangent is equal to 2 from the previous page right here. And that's how you find your slope. Pretty simple, huh? Okay, now we're going to look at a problem a little bit differently this time, okay? It's the same process, though. If I have the point A right over here again, and then I add an h right there, what is this value? It would be a plus h, correct? This is f of a. Here's your function. This y value would be f of a. And the function at that point would be, this distance would be f of a plus h. So by definition, f prime of x, f prime of a at a point is equal to the limit as this h is going to come towards 0 now. Okay, so I'm going to go h as h approaches 0 of f of a plus h, y2 would be a comma f of a plus h, y2 minus y1, f of a all over x2, which is a plus h minus a. Notice that these cancel out, and you end up with just h right there. So that's the definition at a point. Alternate definition, f prime of a is equal to limit as h approaches 0 of f of a plus h minus f of a all over h. So let's look at example number 2 from the book. Okay, I'm going to use my nice pen here. Example number 2. I believe this is on page 145. So example number 2 says find the equation of the tangent line with a hyperbola at y equals 3 over x at 3 comma 1. So when you plug in your x value as 3 in here, 3 over 3 becomes 1. There's your f of 3. So this is your a, this is your f of a. Make sure you write it on top of there, that way you kind of know which one is which. And f prime of a is equal to the limit as h approaches 0. I'm just going to recopy this. F of a plus h minus f of a all over h. So that becomes the limit as h approaches 0. F of a plus h, we're just going to plug in a plus h wherever there's an x right there. Since the function is 3 over x, f of a plus h would become 3 all over a plus h. So wherever there was an x, we replace it with a plus h right there. So it becomes 3 over a plus h. Oh, a was, by the way, 3, right? As well. 3 is right here, 3 is right here. Minus f of a, f of 1, right there, is going to be 1 all over h. Now, this is where it gets a little bit tricky. Sorry about that, 3 over 3 plus h. The way the book did it, I kind of don't like because it's kind of tricky the way they do it. We have what's called a complex fraction. We're going to change that and we're going to bust that fraction. It's called BTF, just for short. It's pretty important, so I'm going to call it BTF, bust that fraction. I'm going to multiply the numerator and the denominator by the LCD. The LCD happens to be 3 plus h. So I'm going to multiply it by 3 plus h in the numerator and 3 plus h in the denominator. What I'm effectively doing is I'm multiplying this number by 1, right? And so we distribute with this here and here. And we're going to get a real simple fraction. So let me try that. That would become limit as h approaches 0. 3 plus h times 3 over 3 plus h. So let's do this right here. 3 times 3 over 3 plus h times 3 plus h all over 1. That's the same thing as 3 plus h. Notice these cancel. You end up with just 3. Minus 1 times 3 plus h is just minus 3 plus h. Do not distribute the denominator. Keep it factored. H times 3 plus h. You will notice something, that the 3 and the minus 3 will cancel. And so what do you have in the numerator? Well, I hope you didn't say h. It's the limit as h approaches 0. Minus times a positive is minus h all over h times 3 plus h. You notice that the h's will cancel out. If by chance it becomes negative 1 right there, if it doesn't cancel with this h at the base, at the denominator, then you will have a problem. So you got to make sure that you cancel out your h's somehow. If it doesn't, then you did something wrong. So there's a little bit of algebra involved here. You end up with negative 1 all over 3 plus h. Now the limit as h approaches 0. I'm going to use lime green here. So I'm going to plug in 0 here. This turns into 0. And end up with negative 1/3. So what did we just find? We found the slope tangent. You have a slope, you have your point. Your point is, where was my point? It was somewhere here, 3 comma 1, there we go. So your slope is equal to negative 1/3. Your point is 3 comma 1. We're going to use the point slope form. Do you guys remember the point slope form? Y minus y1 is equal to m times x minus x1. There's your point slope form. Your point, this is x1, y1, and that's your slope. So You just plug it in. You see that? That's your point, and that's your slope. What was the point slope form? Can you recite it really quickly? Okay. I hope you recited it. Y minus y1 is 1 is equal to m. M is negative 1/3. It's right here. Times x minus 3. That's that 3 right there. And that's your final answer. So you found the equation of the line going through 3 comma 1, and your slope, tangential slope, is negative 1/3. I am going to go over one more thing with you, just in case. I'm going to look at velocity now. What is velocity? Velocity is just another word for speed with direction. Speed with direction is defined as velocity. In other words, if it has a magnitude and direction, it's called a vector, which is called velocity. So basically, think of speed with direction as velocity. A velocity, by definition, would equal the change in distance over the change in time. Here's an example. 5 mph. That's a fast walk, by the way. So you're going 5 miles, the change in distance, per hour. Okay. If you're walking really slow, you're probably walking about 2 miles per hour. Or sometimes they say it change in y over change in t, time. This is called, the book, they call this displacement. Another word for displacement, if I started at this point, I'm going to use a different color. If I start at this point right here, t equals 0, and I ended up at t equals 1, it could be 1 hour, 1 minute, 1 second, 1 hour, 1 day, whatever. And then I went woo like this, and then I ended up here, and time t equals 1. The net distance is called the displacement. You notice I said net distance. I don't want the total distance. I want the net distance. Okay, so displacement is a change in the position over some time. Okay, so what is velocity? Instantaneous velocity. By definition, that's the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay. I'm going to do an example for you. I believe it's on example 3 on page 146. So let me get to page 146. Do they use the same formula? Yes, they did. Perfect. Actually, it's on page 147. Yeah, no, actually 146, right. So what does it look like? You have a tower, which is 450 meters. And you have your position function. The position function is your distance function. They call S of t, usually this stands for position function, which is equal to, I believe, negative 4.5 t squared. No, 4.9 t squared. And what else did they give you? At t equals 5, find v instantaneous, the velocity, instantaneous velocity equals, and then find the velocity when it hits the ground. So how do we do something like that? The velocity at a is equal to the limit as, yes, they use h approaches 0 of f of a plus h minus f of a all over h. Our a value is this value right here, 5. This would be 5, this would be 5, this, and h is a value. So that becomes, if I put 5 in here, what's the position at 5 seconds? I didn't do this ahead of time. It's 4.9 times 25, which is 122.5. Actually, they just go f of 5 plus h minus f of 5. Okay. Which f of 5 happens to be 4.9 times 5 squared, right? F of 5 happens to be 4.9 times 5 squared, 5 plus h. Right? You're going to plug in 5 plus h. 5 plus h squared minus 4.9 times 5 squared all over h. Now it gets a little bit tricky. I'm going to use a new paper for this, okay? So limit as h approaches 0, 4.9. I'm just going to put 5 plus, I'm just going to rewrite it. Squared times 4.9 times 5 squared all over h. I'm going to have to distribute this out. 5 plus h quantity squared is 5 squared plus 5 times h is 5h times 2 is 10h plus h squared. So it's going to be 4.9 times 5 squared plus 10h plus h squared minus 4.9 times 5 squared. You will notice all over h, of course, and the limit as h approaches 0. 4.9 times 5 squared is the same as 4.9 times 5 squared. You notice that all the terms of f of x will usually cancel with something in the inside and the front side. So I'm going to use blue. 4.9 times 5 squared will cancel that. Because 4.9 times 5 squared. So literally what you have is limit as h approaches 0 of 4.9 times. I'm going to factor out an h here as well. It'll be h times 10 plus h. If you distribute this, you notice it's 10h plus h squared right over here, all over h. You see why I did that? Because now I can cancel out my h's. Now you can plug in 0 at this stage. You couldn't plug in 0 before because it would be division by 0. As soon as we canceled it, the limit does exist now. It becomes 10 plus 0. It's going to be 4.9 times 10, which is equal to 490. What would be the units for that? Oh, I'm sorry, not 490, 449. And it's going to be in meters per second. This is the metric system. Gravitational pull in the metric system is 9.8 meters per second. Okay. Oh, squared. My bad. There's a reason for that too, but we won't get into that. So the velocity is actually 49 meters per second. Part B, that's part A. Let's start with the equation again. S of t is equal to 4.9 times t squared. So what I'm going to do is try to find when this distance is 450 meters, right? Because at the very beginning, it says when it hits the ground, I want to find the velocity. So when the object goes down and hits it, I need to know that instantaneous velocity. I know that the position is 450 meters. It's equal to 4.9 t squared. So what I'm going to do is I'm going to divide it by, okay, 4.9 t squared is equal to 450. I'm going to divide it by 4.9 to both sides. Cancel out the 4.9. So t squared is equal to 450 all over 4.9. How to get rid of the squared? I'm going to square root both sides. And canceling out the square and the square root, I end up with just t. Square root of 450 all over 4.9, and which happens to be approximately 9.6 seconds. That's how long it took to hit the ground, minus, there's going to be no air resistance on this, So it's going to take approximately 9.6 seconds if there's no air resistance. Air resistance causes what's called terminal velocity. We're not going to be worried about terminal velocity for now. Okay, so previously what we had was we had 4.9 limit as h approaches 0. We actually had this equation right here. 4.9 times 10 plus h all over h, which was 0, right? 10, what was 10, the value? It was a little bit different value. Actually, what I'm going to do at this situation is the velocity at point time t is 9.8 t. I'm going to get to this a little bit later on, maybe, and show you how I got it. And so you end up with velocity at 9.6 is equal to 9.8 times 9.6. Let me calculate that. 9.8 times 9.6. You end up with 94.08. Approximately 94 meters per second. That's very fast, extremely fast. 94 meters every second. So how am I going to do something like this? Find the velocity. I'm just going to make a proof for you a little bit differently. Limit as h approaches 0 of f of x plus h. Instead of a, I'm going to put x minus f of x all over h. It's the same process. That's, excuse me, v of t. And so f of x was equal to 4.9 t squared. So it'll be 4.9 times t, sorry, x plus h squared minus 4.9 x squared all over h. Distributing this out, 4.9 times x squared plus 2xh plus h squared minus 4.9 times x squared. You notice that 4.9 x squared, 4.9 x squared will cancel just this term. So you get 4.9. I'm going to factor out an h again here. I get 2x plus h all over h. It's a little bit of algebra involved, so make sure you can do the algebra on these, okay? Now these cancel. This one turns to 0. Now we plug in 0. It's going to be 4.9 times 2x. And there it is. Remember, f prime of x, which is velocity of time t. Remember, the derivative is the velocity, okay? It's 4.9 times 2 is 9.8 x. And so that's how we got to here. 9.8 times t, 9.8 times x, same thing. T usually stands for time, so we're going to change this to t here. Okay, so 9.8 times 9.6, that's the time that it took to fall to the ground from 450 feet, is 94 meters. Okay, that's part one. Good luck on your homework, and then I'll give you part two later on.